Imagine being asked a simple question. Which country has an area larger than the United States and Canada combined? In 2025, you'd likely answer Russia. But in 1940, the correct answer was the Soviet Union, 22 million square kilometers, dwarfing North America's 19 million. This tiny shift in time isn't just a trivia quirk. It reveals a profound challenge for artificial intelligence. Can a model truly reason through history? In our latest research, we put this question to the test. Not with a modern quiz, but with a real, forgotten 1940 Norwegian trivia book called Vet de Det, anonymously published by Eugen Raven. It's not just a collection of facts. It's a time capsule. We designed a new task, temporal reframing, a challenge where models must answer questions as if it were 1940. Not just recall, but rethink. Pretend you don't know about the fall of the Soviet Union. Ignore the existence of the internet. Forget that Norway's population has tripled. This isn't about raw knowledge. It's about cognitive time travel. And here's the kicker. We don't think any of today's large language models were explicitly trained for this. No dataset exists teaching them how to pretend they're in 1940. So if they succeed, it's not because they were told to, it's because they reasoned. Let's break down what that means. Traditional question answering treats LLMs like encyclopedias. You ask, they respond. But temporal reframing flips that. It demands deductive reasoning. If the world was as it was in 1940, what follows logically? But it's not pure deduction. Sometimes the model has to fill gaps. What if it doesn't know the exact area of the Soviet Union? Then it uses abductive reasoning, the best possible explanation based on partial evidence. And that's where things get interesting. We tested 4 major LLM families, DeepSeek R1, Gemini, Llama 3.1, and QN3, across a wide range of sizes from 1.5 billion to 405 billion parameters. We also tested 3 Norwegian-specific models, the Mimir series and the brand new Norwa AI Magistral 24B, the largest publicly available Norwegian reasoning model. All questions were in Norwegian, but we prompted them in both English and Norwegian. Why? Because language matters, not just for translation, but for how models frame the task. We used a clever trick for evaluation, LLM-as-judge. We didn't grade manually. Instead, we used OpenAI's GPT-os 120B, a powerful model trained on vast knowledge, not to answer but to judge. It was given a question, the model's answer, and the correct answer from the 1940 book. Then it had to decide, is this right? Output just T or F. Now here's a critical point. We found 9 cases where the grader marked a correct answer as wrong, because of extra detail or a minor spelling variation. In one case, the model answered 236 years to a question about Gibraltar's ownership, while the book said 250. The model was closer. The grader missed it. So we adjusted scores up by about 1 percentage point for the top model. But the core finding remains, even the best models struggle. Let's talk results. Performance scales with size, no surprise there. The larger the model, the better it does. But it's not linear. Take DeepSeek R1. The 671B model scored 85% on English prompts, but dropped to 82.7% on Norwegian. The 7B version, just 14.2%. Same trend across the board. Llama 3.1 is an outlier. Its 405B model actually performed better on Norwegian prompts, by 4 percentage points. Why? We don't know. But it's a clue that some models may be more sensitive to linguistic context than others. Now here's what surprised us. The Norwa AI Magistral 24B model, despite being Norwegian only, scored 75.5% on English prompts and 76.2% on Norwegian. That's within striking distance of international models of similar size. And that's not just about data. It's about architecture. Magistral is built with chain-of-thought reasoning in mind, step-by-step logic. That might explain why it handles ambiguity better. But the real challenge, the 21 questions that every single model got wrong. Let's look at one. What is the biggest name in Norwegian speed walking? The model answers Sonja Hennie. But speed walking in 1940 was called gangsport. Sonja Hennie was a figure skater. The model didn't know the term. It conflated it with a famous name. Another, what is Norway's strongest lighthouse? Answer, strongman Joe Vistel. For means both lighthouse and guy in Norwegian. The model took it literally. It answered a person's name because it misread the homonym. These aren't mistakes in knowledge. They're semantic drift errors, words that changed meaning over time. And here's the deeper issue. The model confidently hallucinated. It didn't say, I don't know. It gave a plausible-sounding answer, complete with a name, a date, a biography. That's the danger of temporal reframing. It's not just about getting facts right. It's about knowing when to stop. We also found that some questions in the book were problematic. One asked about the popular name for Christian V's 1687 law. The book says Christian K. Vint, but the model answers Kong Christian den Femtes Norsk Love, a correct name but not the nickname. But wait, there's a bigger picture. The book was published in 1940, during Nazi occupation. We reviewed it for bias. Found 4 questions using the Norwegian term for Jews, but none were derogatory. 3 used the term Negro, not offensive in context but offensive today. We removed those from the score. but the strongest models still answered correctly. Their answers were neutral, accurate, and respectful. So what does this all mean? First, temporal reframing is not trivial. Even the largest open models don't solve it. They're good, but not perfect. They rely on implicit knowledge, not explicit training. Second, language matters. English prompts help most models, but not all. Llama 3's 405B model did better in Norwegian. That suggests a deep linguistic alignment we don't yet understand. Third, Norwegian models are catching up. Norway AI Magistral 24B proves that a model built for a language can outperform generalist models on language-specific reasoning tasks, especially when it includes reasoning architecture. But there's still work to do. We need to explore quantization effects, how reducing precision from 8-bit to 4-bit impacts temporal reasoning. We only used one level, but we suspect performance drops, especially on subtle reasoning tasks. We also want to test instruction data. What if we train models specifically on 1940 trivia? Could we build a time travel mode for LLMs? And finally, retrieval-augmented generation. What if we gave models access to historical documents from 1940, newspapers, encyclopedias, maps, before answering? That could bridge the gap between memory and reasoning. This research isn't just about trivia. It's about what it means for a model to understand time. Can an AI think like a person who lived in 1940? Not perfectly, but closer than we thought. And that's the real breakthrough. We're not just testing what models know, we're testing how they reason across time. So next time you ask an AI a historical question, remember, it's not just retrieving facts. It's pretending to live in the past. And if it gets it wrong, it's not just a bug. It's a window into the limits of artificial reasoning. Because at the end of the day, the most human thing an AI can do is imagine a world that no longer exists. And that's not just a skill. It's a sign of progress.